All right, I guess we'll get started. It's 8:30. So today's topic is, we've started using objects now in the course. So today I'm going to show you how to use lists in Java. Okay. So we've already seen arrays in Java, right? The array syntax in Java is similar to the Python syntax where you index into the array. But unlike the Python lists, Java arrays you can't resize, right? So you're stuck with a fixed size. And there's a few other differences as well. Lists are the closest thing in Java to Python lists. Okay? So they provide similar functionality to lists in Python, but the syntax is quite different. Right? So again, you need to go through this translation process of when you try to use a Java list if you're used to the Python programming language. Now, the other thing in Java that you cannot do with the Python standard library anyway is that Java lets you pick between several different kinds of lists. Right? So you're not just stuck using a generic list class. You can actually choose from several. But there's really only two main kinds. And when you get down to it, you almost always use something called array list. Right? So you can find that in the class, in the package java.util. Yeah, in Java util, right? And if you hit that link, you can get to the documentation for the class. OK, now, like Java arrays, one of the significant differences between a Java list and a Python list is that the Java list always holds elements of the same type. Okay? So unlike a Python list where you can put whatever you want in the list, for a Java list, you're always putting in elements that that share a common type. So when you make a Java list, you have to specify what is the type of the element. And that goes inside of this less than, greater than construct, right? This diamond construct. Right? And you only use the diamond construct when you declare the list, when you declare the list variable, and when you call the constructor. Right? So this notation, this less than, greater than sign, you only use this when you're working with what are called generic classes in Java. Right, so this is going to be most of your collection classes. So lists, sets, and maps, which you know as dictionaries in Python. Right? Otherwise, unless you're told, so otherwise you have to refer to the documentation of the class and test and look if the class is generic or not. So much later in the course, we're actually going to be implementing our own generic classes. OK, so here's how you create a list of strings. Right? So we're going to use an array list. Right? So there's my, sorry, let me turn on the laser pointer thingy. This is our variable declaration. Right? So we have array list, and then I want it to be a list that can hold a bunch of strings. So I use the less than, and then string, and then greater than. Right? The name of my variable is t. Right? We always use new to make an object, right? To create a new object. So we call the list constructor. Right? So new array list, blah, 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 string, round bracket, round bracket. So that calls the no argument array list constructor, which makes an empty list. Right? So a list with nothing in it. Now, for any modern version of Java, you don't need the second thing. You don't need the second generic variable there. Right? So you can simply write array list string t equals new array list, and then the empty diamond. Right? And the compiler will figure out that, oh, they want to make an array list of string. Right? Before Java 7, you had to do both. And then people realized very quickly that that was basically redundant. Right? If you have an array list of string on this side, it has to be an array list of string on the right-hand side as well. Right? So the compiler now figures out what is the generic type for you in the constructor call. One limitation of Java's generic type system is that you cannot make a list of a primitive type. Right? So for example, I cannot make, oh, I don't know why that D is there. There's no array list of little I int. Right? You can't do it. If you try to do it, the compiler will say the compiler will flag that as an error. Right? Now, to get around this problem, so obviously, a lot of people are going to want to have lists of floats or doubles or ints or things like that, right? So to get around this problem, what the designers of the language did is they created a corresponding reference type for every primitive type. Right? So corresponding to little b Boolean, there's what's called a wrapper class called big B Boolean. Right? Corresponding to the primitive type little b byte, there's a wrapper class called big B byte. Right? Now the ones you need to know are Boolean character. So character is different than char. Right? Most of these are the same name as the primitive type. It's just capitalized. Character is the one outlier here. Right? So the corresponding wrapper type for char is character. Oh, sorry, integer is the other one. The corresponding wrapper type for int is integer. Right? And so what these wrapper classes let you do is that the compiler will treat them specially, right? And whenever you need, whenever you want to convert between the primitive type and the wrapper class type, the compiler will try to do it automatically for you. Right? So for example, I can have int I equals 1, right? So I is an int, so a primitive type variable, right? I can then create an instance of its wrapper class, right? So big I integer, right? J equals I, so that's fine. That's weird, right? Because you know that big I integer is a reference type, so there should be a constructor call here, right? But Java makes the exception for these wrapper type classes, right? You don't need the constructor call here. Right? You can simply write j equals I, right? And what the compiler will silently do is it will take that value 1, and it will make you a new integer object whose value is 1. Right? So that's called AutoBoxing, right? When you take a primitive type and automatically convert it to its corresponding wrapper type. Right? Similarly, if you have an instance of the reference type, right? So if I have an instance of the wrapper class, so I have j, right? I can assign that value to a primitive type variable, right? So in other words, I can assign j to the int k, right? And now what Java will do is it'll take the value of the integer object, right? So in this case, it's 1, and it'll take the 1 and store that into k, right? So that's called auto unboxing when you go from the wrapper class to the primitive type, right? Auto boxing is when you go from the primitive type to the wrapper class type, right? And so, given the wrapper classes, now you can make lists of the wrapper class type instead of making lists of the primitive type. Right? So if you want a list of int, you make an array list of integer. Right? If you want a list of double, little d double, you make an array list of big D double. Right? And if you want a list of char, you make a list of an array list of big C character. What was that? Something just popped up over here. And I have a feeling someone's complaining about this. Oh, no, never mind. OK, so when you use a list where the elements are a wrapper type, right, you can almost always pretend that the list contains primitive type elements. Right? So yeah, I've got a list of, in this case, integer. But you can more or less make believe that it's an array list of int. Right? So here's my array list integer t. Right? I make an array list object. Here, so when I add an element to a list, right, the element type has to match the type that you declared in the, when you declared the variable, right? So I'm supposed to add an integer object to this list, right? But I don't have to do that. I can simply add the int 100, right? So in other words, I don't need to make an integer object here that corresponds to 100. I can just add 100 to the list. The compiler will automatically convert that 100 to an integer object. Right? So it auto boxes that 100 to an integer and puts that into the list. Right? Similarly, if I want to get that 100 back out of the list, right? So when I get the element out of the list, it's going to give me back an integer, big I integer, right? Because that's what the list holds. But I can take that big I integer object and store it into a primitive type variable without any issues, because the compiler will auto unbox the integer type into an int. Right? So you can more or less just pretend that everything's fine. Right? It's just it basically looks like it's just an array list of int. Right? It's not an issue that you don't have to worry that it's actually an array list of integer, except in one instance. Right? There's one situation where this will surprise you. Right? So when you make a list of integer and you try to use the remove method, you have to be a little bit careful. Right? The reason you have to be careful is because it may not work as you intend, because there's two different versions of the remove method. One of those versions has an int as its parameter. Right? So here I've got an array list t of integer. Right? We stuff some elements into it. Right? And then later on, we try to remove the element whose value is 100. right? So T remove 100, I mean, to most people that looks like, oh, I'm trying to remove the element 100 from this list, right? The problem is it calls T remove with the int value 100, calls the int version of the method. The int version of the method removes the element at index 100, right? Which may not be what you want to do, especially if your list doesn't have 100 elements in it, because then you're going to get an exception. Right? If you really want to remove the first object whose value is 100, then now you have to make the integer object yourself. Right? So now you've got to do this integer thing. So here, the way you remove the first element whose value is 100 is you make an integer object. Right? Here you can't rely on AutoBoxing in this case. Right? So now you have to do something like integer dot value of 100. Right? And that returns an integer object whose value is 100. Right? You no longer use the constructor call here. Right? You used to be able to write new integer 100, and the compiler would be happy with that. If you do that with a modern version of Java, the compiler will say, will issue a warning. Right? It'll say the constructor call is deprecated, meaning you're not supposed to use it anymore, and you should use this value of method. There is a good reason for that, but it's not important for us right now. Right? But there is a reason why you're not supposed to use the constructor. OK, so you know there's lots of things you can do with a Python list, right? This is only a partial table. Right? Lots of things you can do with a Python list, right? Almost everything you can do with a Python list, there's a corresponding way to do it in Java, right? Unfortunately, the corresponding way to do it in Java is almost always involves more writing. Right? So first line, T equals the square brackets in Python, right? That makes an empty list in Python. Okay? I'm going to assume that we're working with lists of strings in this table. Right? So to make an empty list, an empty array list of string, you have to write the thing on the right-hand side. Right? If you want to check if a Python list is empty, you can just write if t. Right? You don't have to write if length t equals 0. You can just write if t. Right? You cannot do that in Java. Right? So instead, in Java, you have to call the method isEmpty. Right? Is the list empty? Yes. Do something in the if statement. Right? The number of elements in the list you get in Python using the len function. Right? The number of elements in the list in Java is size. Right? So t.size. Right? Notice you call them in a different way as well. Right? So in Python, there's a mix of using functions with lists, and and methods with lists. Right? So sometimes you write length t, and then sometimes you write t dot something. Right? In Java, it's all methods. Right? So it's always t dot something. Right? The list name dot something. If you want to add something to the end of the list in Python, it's append. In Java, it's add. Right? If you want to get an element, we know it's square brackets in Python, right? And with the Java arrays. In Java, it's get for the list. Right? So tget0 returns the first element in the list, if it's there. Right? If it's not there, you get an exception. Right? To do an assignment, you use the set method. Right? So t.set0 goodbye will set the first element of the list to the string goodbye. Now, there's actually a big difference here. If your list is empty and you do tset0, you'll get an exception. So there has to be an element at this index in Java for that to work. Right? If there's not an element there, you'll get a runtime error. OK. In Python, if you want to check if there's a value in the list, you use valIn. Right? In Java, you use the contains method. Right? If you want to add another list to the end of this list, right? So you want to add all the elements from another list to the end of a list in Python, you use extend. In Java, you use add all. Right? To remove something at a particular index in Python is pop. In Java, it's remove. Right? But again, remember, if you have a list of integer, you have to be a little bit careful with this one. If you want to remove the first element that equals elem in a list in Python, it's remove, and that's the same in Java. Right? So that removes the first element equal to elem in the list. Right? If there's more than one element that's equal to elem, it leaves all the other ones in the list still. You can slice a Java list. Right? So slicing a Java list, you use sublist. There's a difference. What happens in Python? There is a difference here between these two. So in Java, if you change the sublist, right? So in other words, if I start using you to set elements of the sublist, that changes the original list. Right? That's not necessarily the same. I don't think that's the same in Python. It's not the same in Python, is it? I don't remember. I don't think it's the same in Python, though. I think the slice gives you a new list in Python. That's not actually a new list, right? It's part of the original list. This method is really useful in Java. OK, if you want to copy an array, if you want to copy a list in Python, you just use copy, the method. There is another way to do it. You can slice the list, right? In Java, you have to call a constructor, right? So you call a constructor, and this time you call, it's not quite a copy constructor, but it's close enough, right? You can call the constructor and pass in the list that you want to copy, and you'll get a copy of that list. Right? If you want to count the number of times a string ABC appears in the list, you just use the count method. Now in Java, the list class does not, the array list class does not have a count method. Right? So now you have to rely on a second class that can do the counting for you. So that second class is called collections with an S. Right? There's the link to the documentation. Right? There's the package that the class lives in. Right? So that class called collections contains a bunch of static methods that operate on lists. They also operate on sets. But we'll get to that in a lecture or two. Right? So there's a method called frequency, right? Where you tell it the list and the thing that you want to count for occurrences in the list. Right? So that'll count the number of times the string ABC appears in the list T. Right? Reversing a list, there's a method for it in Python. In Java, there isn't. Right? So again, you rely on the collections class to do the reversing for you. Right? And similarly with sorting, sorting, there is a method in Java. Well, they added it. I can't remember in which version. It's either 8 or 9. To sort a list, though, you can do tsort null. The null is important. It has to be there. Or you use the collections class and do collections.sort t. Right? So that'll sort t. So that'll actually change t, the ordering of the elements in t, so that t is sorted. Now in Java, when you do that, your element type has to be sortable. Right? So you can sort strings in Java, that'll sort in dictionary order. Right? You can sort integers in Java, that will sort in numeric order. But for example, if you had a class called student that represents students, you may not be able to sort a list of students. Right? There's a way in Java to define a class so that it is sortable, so that objects of that class are sortable. Right? But we'll get to that in a few weeks. OK, so null we haven't talked about yet. Null means no object in Java. Right? So if you have a reference variable, so like string or list or array list or something like that, you can give it the value null. Null literally means there's no object there. Right? So you can't use the reference for anything. Right? If you try to use the reference for anything, so if you try to call a method with it, it'll barf. Right? Because you're using no object to call some method. It's needed here because that method actually takes in some object, right, called a comparator. And the comparator object knows how to compare objects. The comparator is an object that knows how to compare elements of the list. Right? If you pass in null, then you get what's called the default comparator, which sorts from smallest to largest. Right? OK, so there's the big. Is that it? That's not complete. There's other things you can do as well, but those are all of the common operations that you would do with the list. Right? Iterating over the elements of a list, that's very common as well, right? So it's almost identical to iterating over elements of an array. Right? So you have two different loops that you can you have 3 different loops that you can use to iterate over the elements of a list. Right? So in this example here, I'm going to assume T is not empty. Right? So T has some elements in it. And this is important. Right? I want to find the shortest string that's in that list T. Right? So I start out by assuming Right? The first element of the list is the shortest string that's in the list. Right? Now, this is why I had to assume that the list is not empty. Right? Because if the list is empty, t get 0 will throw an exception. Right? Because you can't get an element out of an empty list. Right? So that's why there's an assumption up here that the list is not empty. Right? So get the first element of the list and assume that's the shortest string in the list. Get its length, right, using the length method. And now I can use the Java's for each loop to loop over the elements of t. Right? So the way to read this is for each string s in t. Right? Yep. Oh, sorry. No, okay. For each string s in t. Right? Now inside the loop body, I can use s as a reference to the string that I'm currently visiting in the list. Right? So if s length is less than the min length, right, then I know I found a string that's shorter than the current shortest string. Right? So the min length now becomes s dot length, and the new shortest string becomes s. Right? And that will visit every element of the list, right, comparing the length of each string in the list to the current shortest string. Right? You can write it this way using the other Java loop. Right? So starting from I equals 1, not 0 in this case. Right? I don't have to start at 0, but I could. Right? I don't have to start at 0 because I've already processed element 0 of the list up here. Right? So here I can start at element 1. Right? I still have to make sure that the index is less than the size of the list. Right? Because the last valid index of the list is the size -1. Right? Each time at the end of the loop, I want to increase the index by 1. Right? And now I just use get I. Right? So the old style of Java loop here is a little bit longer than the for each version. Right? It also involves an explicit method, an explicit call to get here. Right? But otherwise, it's the same. In this case, the preference is to use the for each loop. Right? But you can use the old style loop here. So just like arrays, sometimes you have to use the old style loop. Right? So if you need that array index, if you need that list index for some reason, you should use the old style loop. If you're looking at more than one element of the list at the same time, you should use the old style loop. If you're looking at two or more lists at the same time, you should use the old style loop. Right? The newer for each loop won't work. Okay, now I can get rid of this non-empty requirement when I write a method that does the same thing. Right? So here is a method that basically returns the shortest string in a list. Right? So public static string, so it returns a string. The method's called shortest. Its parameter is a list of strings. Right? And now I can check. Right? Is the list empty? And if it is, I can indicate that back to the caller by throwing an exception. Right? And now the rest of the method is the same. Right? When you throw an exception in Java, the method stops running the moment the exception is thrown. Right? So the exception goes back to the caller of the method, and then the caller of the method has to deal with the exception somehow. Right? If they don't deal with it, then the program crashes. It stops running. Right? Once I get past the if statement, I can safely do get 0, right? Because I know the list is not empty, right? And the rest of the method will work just fine. Okay, anybody have any questions about lists? Yes? I don't need an else, no. So if the list is empty, the exception is thrown, the method stops. Right? So I don't need the else in this case. You can put it in if you want to, but you don't need it. Right? So if it's empty, exception gets thrown, method stops, and then if it's not empty, you just keep on going after here. So when do you need an else statement?
Yeah, what's the condition? When you take an else statement?
So when do you need an else part in an if statement? So in this case, the answer is, I'm pretty sure the answer is never in this example. Right? There's no reason to put the else block because you want the stuff here to run. afterwards, right? So whether it's in an else block or not doesn't matter in this case. The only time it matters is when you, so you do something if the condition is true, and then otherwise you do something when the condition is false. So one example where it would matter is if the else statement had another if statement inside of it, or something like that, right? But it's actually the case where you can usually, if you're finding yourself writing if and then else, it's often the case that you don't need the else part. Right? Yeah. Yeah.
Earlier when we were talking about list comparing like the Python and the Java array list.
Yeah.
When you know right at the end when we were talking about t dot sort and then you put null in the argument.
Yeah. Right there.
What collection is that from the collections class as well?
No. So sort is a method that's in the lists. That's in the list class, list interface. So array list has a sort method in it now.
Oh.
Yeah. I don't remember which version it was added to though. I think it was 9. But anyway, you can do it now. It never used to be there though. Okay, so now we're going to do some examples working with lists, right? Okay, so here you're given 2 6-sided dice, right? I want to know what are the odds of rolling a 2, a 3, a 4, and so on, and so on, and so on. Right? In other words, I want to fill in this table, right? And this is a basic probability question that you may have done, I guess, in high school, but you'd certainly do in your first undergraduate statistics course. Right? It's actually just a counting problem, so you can easily solve this using counting methods. But if you can imagine a harder kind of problem where you want to compute the probability of something, right? And it's not so obvious what the statistical answer is, right? In those cases, you can rely on what's called simulation, right? You can write a computer program to do the thing that you're trying to do many, many times and just count up the number of times certain things happen, right? So here I want to write a program that's going to roll a pair of dice lots and lots and lots of times and count the number of times 2 appears, right? Count the number of times 3 appears, count the number of times 4 appears, and so on, and so on, and so on. Right? And I want to store the number of times 2 appears in a list, right? And the number of times 3 appears in a list, and the number of times 4 appears in a list, and so on, and so on. Right? So the first thing we need to know is how do I generate random values in Java? So there's a class called Java util.random that lets the programmer make an object, a random object, that can generate random numbers. Right? It'll generate random booleans, ints, longs, floats, and doubles. Right? If you want to generate like random strings or things like that, you have to either find some other class that can do it for you or write your own method to do it. Right? If you want to know how this class works, you can hit that link there. Right? Essentially, the very, very simple explanation is it basically computes some mathematical function and it spits out some random number. Right? If you want to find the documentation for it, you can just hit that link there. Right? Okay, so if I want to compute the odds via simulation, right, basically you perform the following steps. So I want to make a list, and I want to add 13 zeros to the list. Right? So why do I want 13? Because I want the list index at element 2 to be the number of times you roll a 2. Right? And I want the list index at element 12 to be the number of times you roll a 12. Right? If you go up to index 12, that means there's 13 values in the list. Right? So I'm going to stuff 13 values in the list. If you wanted to, you could just put 11 in, right? And then the element at index 0 would be the number of times you rolled a 2. Right? And the number of times you roll, and the element at index 10 would be the number of times you rolled a 12. Right? But it's a little easier just to use the values in this case. Okay, and now you just repeat the following n times, right? Where you're going to choose a large value of n, right? So that's a loop. Inside the loop, you roll 2 dice, you sum their values to get x, right? And then you just add 1 to the value at index x in the list, right? So the list is just keeping track of how many times you rolled a 2, 3, 4, 5, 6, 7, 8, and so on, right? To compute a proper probability or odds, you just divide every element in the list by n when you're done, right? And let's give a shot at doing this in Eclipse. So let's see what happens. OK, so sorry. First thing I want to do is I want to make a list and add 13 zeros to the list. OK, so here's my dice sim. Right, got a little dice sim class. I got a main method, so I can actually run the program. So the first thing I want to do is I want to make a list. Right, array, list. What's the list going to hold? It's going to hold a bunch of integers, right, the counts. And so I'll just call it count. And that's equal to a new array list. Semicolon. Right, so notice when you do that, Eclipse complains. Right, it's going to complain it doesn't know what array list is. Right, so go ahead and, in this case, you can choose the first one because that's right. Right, I want to import the array list class. Right, so the error goes away. That's step one. Step two is repeat something n times. So I'm going to do final int n, and I'm going to use the number 1,000. OK, so a final primitive variable in Java is a constant. Right? So when you use the word final in front of the variable type and name, right, that says that you can only assign the value of n once in the program. Right? So here, when I write equals 1,000, that's it. Right? N will forever be the value 1,000 in this method, right, inside this method. Right? I can capitalize it here because it represents a constant. Right? Otherwise, you would use a lowercase n. Yes?
So is there any benefit to making it a constant instead of an integer?
Yeah, so in this case, the benefit is I can't change it later accidentally. Because the value of n is going to be important, right? Because I'm going to divide everything by n at the end. So if I accidentally modify n somewhere between when I first use it and when I last use it, that's going to be a problem. I'm going to get the wrong result. So here it's a small safety thing in this case. Right? And I want a loop that runs that many times. So right, I equals 0, I is less than n, I plus plus. Right, so there's my loop. Now I need to roll 2 dice and get their sum. So that sounds like something that might be worth writing a method for. You don't have to, but let's do it that way. Right? Everything's static for the time being, but that's going to change shortly. I'm going to roll 2 dice. I'm going to return their sum. So that I'm going to return an int. We'll call it roll. Right? Now, how do I roll 2 dice? Well, I need to generate their values. So I need an object that can generate random numbers. So I just told you that's called random. R equals new random. I can do that. That's fine. Right. Again, Eclipse complains because it doesn't know what random is. So hover, import. Yes, that's the right one. Right. You always make sure that it's the right class that you're importing, because there could be 2 classes with the same name. Right. If you import the wrong class, things get very confusing because you can no longer call methods that you think should be there. OK, so I want 2 values, right? So let's call them, what do we want to call them? I don't know. A? Sure. RNG. OK. What value do I want to call to get another integer? So let's look at this one. Next int. Right? Tells you it returns a blah, 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 random value, random int value between 0 and the specified value, exclusive. Right? So I want values between 1 and 6, but this is going to give me back values between 0 and something. Right? But it looks like it's the one I want, so let's try it. OK, so I want values between 1 and 6. It's giving me back, if I do that, right, it'll give me back values between 0 and 5. Right? I can get 1 and 6 just by adding 1 to it. Right? There we go. Right. I want a second die, so that's B. Right? Same thing. Right? I need to get a random value, so I'm going to use next int 6 plus 1. Right? If you're being very particular, right, you would turn that 6 into a constant as well. Right? I'm not going to do that, but you might consider doing that. And now I just sum A and B and return the result. Right? So return A plus B. And there's my roll method. Right? So now down here, I can just say int z equals roll. Right? And now What am I supposed to do here? Oh, wait, I'm supposed to be x, right? I think I called that x in the slide. Right, it says, yeah, sum their values to get x. Add 1 to the value at index x in the list. OK. Add 1 to the value of index x in the list. So I'm going to do count x. Oh, wait, I can't do that. Count set element index x to whatever the value of count is at x right now. Plus 1. Right? So count get x gives you the current count for whatever you just rolled. Right? So if I rolled a 4, count get 4 is going to give me how many times I've rolled 4 so far. Right? Add 1 to it and put it back in to the list using set. Right? And we're done. Oh, wait, I have to now divide every element of the list by n. Right? So after I do this thing n times, right, I now go through all the elements in the list and divide them by n. Now, I cannot use, you can't use the for each loop. Does anybody see why? Here, let's write the for each loop, and you'll see why. Integer, for each integer I in the list count. Whoa, sorry. I have no mouse, and I have a really tiny keyboard, so it's really hard for me to type. OK, so I can't use this version of the loop, because I need to go in and I need to divide every element of the list. Right? In other words, I need to write count.set something, something, something. Right? But I don't have an index in this case. Right? All I have are the counts. So I can't do it this way. Right? So I have to go back to the old style loop. So int I equals 0, I is less than the size of the list. Right? And now I want to do count.set x to count.get x divided by n. Oop. Right? Doesn't know what x is because it's supposed to be I, sorry. And then when I'm done, let's just print out the list and see what we get. Oh, wait, sorry. List is called count. There we go. Right, so you can print out a list, and Java knows how to print out a list. Right? The way this actually works is that the list object, the array list object has a method called toString. Right? And the toString for a list will actually print out the elements of the list. And so when you pass in an object reference to the print type methods, Java automatically calls toString on the object for you. Right? So in other words, Java automatically calls toString on count for you, and then it prints out the resulting string. And let's see what happens. Hopefully I got this right. I did not get it right. What did I do wrong? Index 7 out of bounds. Good. What did I forget to do? I forgot to put in the 13 zeros up here. Right? So you get an index out of bounds exception when you try to access or set an element of the list, right? Where there's no value there, there's no current value there. Right? So here I'm using an empty list. So when I try to set something here, you get this exception, right? Because there's no element there to set. So I have to write another loop. Now I need to do this 13 times. Right? Again, that 13 would be a good candidate for a constant. Right? So count dot add, and I'm supposed to add 0 to the list. Super. And now we try it. We get all zeros. Why do we get 0? Anybody, anybody, anybody? What's the element type in count? It's integer, right? So when I do count get I, that returns back an integer, right? Which Java converts to an int. N's also an int, right? So that's going to do integer division. Right. n's definitely bigger than the counts, so that's always going to be 0, right? So the type of count can't be integer, unfortunately, in this case. Right? So now we run into another problem. Right? I now have the problem where, right? If the counts are to represent real numbers, then I have to make a list of double here. Right? But when I make this a list of double, there's going to be other problems. So let's see what happens here. So double. Well, there could be other problems. So I'll change that to double. Count add 0. Right? The method add int double in the type array is not applicable for the arguments int and for int. Right? Count add. So I can't add that, so I have to doop, boop. There we go. Right? So I have to add the value 0.0 to the list. Is this going to work? That's okay. That's okay. That's okay. That's okay. Okay. Now we see what happens, and voila. Okay. So the first two values are 0, but that's what we expect, right? Because you can't roll 0 when you roll 2 dice, right? And you can't roll 1 when you roll 2 dice, right? Now what about the other values? So back here, I said it was roughly 3%, then 5, then 8. And what's Eclipse giving us? Roughly 3%, roughly 5%, roughly 8%, and so on and so on and so on. Right? If you make that number n bigger, like 10,000, and run that, those numbers will get closer to the expected values, right? To their expected statistical values, right? And if you keep on making it bigger and bigger and bigger, eventually it will converge to a value that's very close to the true statistical values, right? Okay. Any questions? Anybody? Anybody? All right. One more example. Oh, no, there's supposed to be another one here. Okay, the coin flipping simulation. So this is pretty similar, right? This time I want to flip a coin, right? I want to flip it n times, right? So where someone can specify the value of n, right? If I flip a fair coin n times, how many heads do you expect to see on average? Right? So if it's fair, you expect to see n over 2, right? But you should not be surprised if you see some other number, right? So if I flip a coin 10 times, right, you should not be surprised if you get 3 heads, right, or even 2. You might be surprised if you only get 1 or 0, right? But it's not really that uncommon an occurrence, right? Now the question is can you actually predict how many heads you should see if you're doing this experiment, right? And the answer is yes. You can click on that link if you want to see what the answer is, right? You probably do this in your first year statistics, in your first statistics course at a university level, right? You might do it sometime in high school if you're going to a really advanced high school. But what I want to do is I basically want to make this table here, right? Where 0 is the number of times I see 0 heads, right? 1 is the number of times I see 1 head, and n is the number of times I see n heads, right? The value I want to store are probabilities, right? So again, I'm going to need a list of doubles in this case, right? It's just about quarter after, so I'm going to stop there, and I guess on Monday I will do this in Eclipse, or I'll just show you the final program, right? But if you keep on going through, it tells you how to do this. So if you want to try this on your own on the weekend, please feel free, right? And don't forget the assignment is due Monday if you haven't finished it yet.